So look what I found. 1 times 10 to the 9th. A 1 with 9 zeros after it. What is that? 1 billion. Okay? So my calculator says we got to 100%. It rounded. Okay? The calculator can only hold a certain number of decimals before it freaks out, and it's freaked out. It has rounded to the next whole number. Okay? Do you know enough about these kind of properties to know that it didn't actually get to 100%? That's important. Okay? Because there's somebody who would sit here holding this down just to see if I was right or if I was wrong, because I said it would never get to 100, right? And it did. It did get to 100 in the calculator. Okay? But please understand that what actually happened was that the calculator couldn't handle such big numbers anymore. And it went ahead and rounded. Okay? We okay with that? All right. So when will it reach 100%? Never. Okay? Often when using rational functions, hush please, when you plug in larger and larger numbers for x, God bless you, the answers to y keep getting closer and closer to a certain value. This value is going to be really, really important for you to know next year and the year after if you make it to calculus. Okay? This value is called a limit. Okay? It's called a limit. In the basketball problem, what was the limit on Charlie's percentage? The limit was 100%, right? Is it going to get to the limit? No, but that's what it is approaching. Okay? So we can say that the limit is 100. It's not going to get to 100%, but that's what it's approaching. Does that kind of make sense? It's a good start anyways. Okay? Graphically, this makes an asymptote. What kind? Horizontal. So, I've got 8 problems here. If you did not volunteer for one last time, please volunteer for one this time. I need you to put the equation in y equals and look at these 4 specific numbers. As a reminder, I want to show you what we can do. Yes, you can put it in y equals and go look at the table, adjusting your table count by thousands. But remember I told you this a couple weeks ago that I learned at the symposium, that math thing that I went to? You can menu, where is it? Define, right there. We can define g of x or f of x or whatever we want to call it to equal, let's say, x minus 4 over x minus 2. And then I can ask the calculator for g of 1,000. And it will tell me. That's not really nice. Let me see if I can do it this way. G of 1,000. But this time I'm going to hit Control equals because that will give me, it should give me the decimal. And that's what I need. Okay? So I need these 8 done. Can we do it pretty quickly? I'll have to write it on here since we are making the recording. Okay? You got 8? Read it.
1,000 is 499.998.
Okay.
And then 2,000 is 999.999.
Okay.
3,000 is 1,500. And 4,000 is 1,000.
Okay. Anybody want to correct my error on number 1, by the way? Okay, I do. It should just be that, because if we're going to round it, it's got to be appropriate rounding. When you get one, read it to me. Number 7? Yeah, that'll work. Okay, So you're going to have to give me like 4 or 5 decimal places for it to make sense. 2, 4, okay. 6, 062. Okay, sorry about that. Uh-huh. 3, 1. All right. Number 4. What you got?
2002.002.
Okay, we'll just go with that.
Oh, okay. So do you want to? Okay. They're all basically like the same. So 4002.
Okay.
6002.
6002.
Yes, sorry.
That's fine. You're fine.
80 or 0.
You got 6? Read it to me. Okay, this is a really good question, and I don't know. You know what I'm saying? I don't know how many decimal places I need. On Monica's, I didn't need any because this was enough to tell me what I needed. On Luke's down here on number 7, we started with 3 and realized that wasn't going to make any sense once we got here, and it was 0.000. So I knew I needed some more. So you tell me what you think that I need to be able to see what I need to see. Fair enough? Okay? Again? Okay, you're fine. You're fine. What's the second one? 438. Okay. Okay. Two 1 9. Okay. Read 5. Okay. 0.000833. Okay.
0.000556.
Okay.
0.0004.
So did you not tell me another decimal place here? Because it would have been another 6 and that would have freaked you out. Oh, okay. Just asking. Oh, okay. So we just left it off. Okay. What about 2 and 3? Anybody got 2 or 3? Is anybody doing 2 and 3 for me? Okay, thank you. I think probably that's everybody, because we did 9 before and there's 8 now. Well, there should be 2 people still haven't done one. And Luke went twice, so some people are slacking. Okay, 2. Okay. Got it. 6. Okay. What you got? I got some juniors in here. Dance classes on Saturdays for prom. Okay? Okay. No, just read me the decimals. It's fine. Okay. 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 What was this one?
Oh, I get it now.
Okay, so do we have the tables filled in? Everybody have your tables filled in? Ask me. Right here? That's the 0.998 that I rounded incorrectly. And this is not rounded correctly either, but there's like lots of nines, and I could have just gone to 9, but I don't know. 9. Don't judge me because of my numbers. I'm just a math teacher. Okay, ready? Predict the location of a horizontal asymptote by finding the limit. Okay? It says by plugging in extremely large numbers. Well, that's what we did. 1,000, 2,000, 3,000, 4,000. That's continually large numbers, right? So as I plug in larger and larger numbers for x, where is y going? What is it approaching? It's getting closer and closer and closer to 1. Y equals 1. Is it ever going to get to 1? How do we know that? There's an asymptote there. Okay? What about number 2? Can you tell what that's getting closer and closer to? Y equals 0.5. That's a good point, though. It is past 0.5, but it's actually coming down to 0.5, right? Okay. What about number 3? Jonathan, you cannot answer anymore. That's really close. Jonathan? It's still not right. It's not -2. It's closer to what they were saying, but...
Miss Kingston?
Yes, ma'am.
Can I have Tanner Broadfoot to the office, please?
Yes, you can.
Thank you.
Which is what? 1 2/3. Negative 1 2/3. Hustle back, please, okay? What about number 4? What's it approaching? Is it approaching anything? What is it doing? It's just getting bigger, right? None. There's not going to be an asymptote there. Okay? What about number 5? Yep. Y equals 0. What about number 6? Y equals 2.5. Good. What about number 7? Y equals 0. And what about 8? Nothing. Basically, it was 500, then 1,000, then 1,500, then 2,000. Right? Okay. Is there any way to tell the location of horizontal asymptote just by looking at the function? Look at the functions. We tell the vertical asymptotes by looking at the denominators, right? How are we going to tell the horizontal asymptote? See if you can figure it out. When you quit guessing out loud, I don't think you're thinking about it anymore. So if you're thinking and you see something, so you're saying if I have a 1 divided by a 2, I should get a 0.5. Does that work? A 5 divided by a 2 gives me a 2.5. But a 2 divided by a 1 is none. So look at this. Look at these. What do you notice about those two? They're the same. Look at these. What do you notice about those two? They're the same. So look here. These are the same. Is that what I wanted? Is 5 over negative 3 negative 1 2/3? Yes. So when same kind of x's, what do? Divide. Okay? For the record, these things in the very front are called leading coefficients. They're the coefficients that are first. They're called leading coefficients. When the variables are the same, when the exponents are the same, I divide my coefficients. Okay? So look at 5 and 7. I got the same kind of answer on 5 and 7. What can I come up with there? Look here and here. It's bigger on the bottom. Is it true here on this one? What's the the exponent here? 0. What's the exponent here? 1. Is it still bigger on the bottom? So if it's bigger on the bottom, then... Now, I need to clarify something for you. I'm saying it. What is bigger on the bottom? The bottom exponent, right? The bottom exponent. All right, so what's the last thing we have to look at? What's the last possibility? 8 and 4, right? What do you mean? The top exponent is bigger on 8 and 4? Here and there? Here and there? So when the top exponent is bigger, there's not one, right? Okay, so go to that other paper I gave you and let's make it all official. What am I looking for? First, I'm looking at the what? I'm looking at the exponents. I need to find the greatest exponent used in the numerator. And the denominator. In each, the greatest exponent is called? Do you guys know? We've talked about this before. Plus it says it down here. Like 8 times. Okay? Now compare. When the degree of the numerator is greater, there's no horizontal asymptote. That's written on your paper, right? So you got to do something to make it stand out, right? What happens when the denominator is greater? Y equals 0. Okay? I'm going to finish this so you can finish this. Okay? When they are the same, when the degrees are the same, you take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. So looking here, the degree of the numerator is 2. The degree of the denominator is 2. Compare them. They are the same. Because they are the same, we're talking about this one. So we look at the coefficients. Y equals 3/5. Looking at number 2, the degree here is 2. The degree here is 1. So the numerator is greater. When the numerator is greater, we have none. No horizontal asymptote. Okay? Problem number 3. That's a 1. That's a 2. So denominator is greater. So we have a horizontal asymptote at y equals 0. And the last one, that's a 3. That's a 3. Degree of the numerator is 3. Degree of the denominator is 3. That's where we look at the, hold on. First of all, they're the same. So we say y equals 4 over 2 or y equals 2. Okay? Peace.